Gametogenesis is one of the more difficult subjects. It's best to not ask too many questions about it. It kind of is best to just explain it and see how it applies. Gametogenesis means production of gametes, which are sperm and eggs, sometimes called follicles. Just want to quickly review what's going on here so we understand. We've talked about meiosis and mitosis. Easiest way to think about it is mitosis is where the chromosome number stays the same, and meiosis is where we halve the number of chromosomes. Every cell in our body is supposed to have 2 sets of chromosomes. So for example, humans have 2 times 23, 46 chromosomes. If you have 2 sets of chromosomes, as all animals, plants do, then we refer to ourselves as diploid organisms, and that's abbreviated as 2N. 2N means you have 2 sets of all the chromosomes. There's one place in your body, however, where we don't have that, where we only have 1 set of chromosomes there. And if we only have 1 set, we're haploid, and those, of course, are the sperm and eggs, which only contain 23 chromosomes, and we refer to that as 1N. It's just listed as N right there. And so we go back and forth, and we create 1N haploid sperm and eggs, which then come together through a process called fertilization, of course, to recreate a zygote, which grows up through mitosis to be an animal like us. Okay, that's the basic idea of sperm and eggs. So let's go ahead and look at what's going on in men. First of all, spermatogenesis. This, of course, takes place in the testes. The testes in the seminiferous tubules contain a whole bunch of cells which are called spermatogonium. They're, of course, diploid, 2N. And they can go ahead and make more spermatogonium by going through mitosis. Chromosome number stays the same. But they can also go ahead and differentiate, and they go this way, and they become primary spermatocytes. Now, these are still 2N, right? So that was a mitosis process. But then we finally go through meiosis, and as you remember, meiosis has actually 2 stages, meiosis 1, meiosis 2. And the final result, of course, is that we halve the number of chromosomes. So as we go through meiosis, we halve the number of chromosomes. Now it's haploid. These are called secondary spermatocytes. 1 makes 2. Then it goes through the second stage. The chromatids break. So we actually don't change the number of chromosomes, but we change the amount of DNA. And they're now referred to as spermatotids. So they're still 1N haploid. So the final result is from 1 single cell, you actually make 4 spermatotids. And this goes on and on and on. We basically make, I think it's something on the order of 300 million every day. Then these guys go to the epididymis, which is on the outer portion of the testes, and they're matured there, tails put on and so forth, and then they're finally referred to as sperm. And this goes on from puberty through the entire life of a man. About 300 million every single day. Quite a process. Now, the interesting thing to understand about this is that this takes place in the seminiferous tubules, but it's not that they're creating sperm, which are then secreted into some area like the vas deferens. It actually is the cells themselves, remember, which are metamorphosizing, which are changing. So just to give you kind of a graphic of what's going on, let's suppose this is the basement layer of the seminiferous tubules, and what's going on is that the cells, as they start to move in this direction, right, they start changing little by little. So spermatogonium changed to primary, secondary spermatids, and finally the spermatids are out on the outside. But remember, these guys here originally started out as these guys. It's not like these guys created them. They actually are them. And then they finally get released into the vas deferens through the epididymis. Okay, that's basically the idea. And there are, of course, other cells in between here which are kind of nursing them along. So, for example, you have Sertoli cells, which are called nurse cells, which kind of help them mature. And you also have Leydig cells down the bottom, which are producing testosterone. And testosterone is really necessary for the production of sperm. Okay, that's what's going on in the male system. pretty complicated, yeah, but unfortunately, the female system is even worse. So the female system is called Oogenesis. Some of it kind of looks the same, but some of it is different. What's similar about it? Well, you start off again with oogonium, which make these differentiated cells primary oocytes. Again, they're diploid, and they go through meiosis. But here's the deal. The meiosis is not a continuous process. It actually pauses. So where's the first pause? Well, we start off right here, yeah, this guy here. Every female is born with all of her eggs already, but they're paused. Yeah, they haven't gone through meiosis yet, and they only get matured 1 a month from either ovary. So then they go through meiosis once a month, right? And once a month, an interesting thing happens. Half of it becomes a secondary oocyte, haploid, 1N, but the other half becomes what we call a polar body, which is not really an egg. And what's going on there is that the cytoplasm and all the organelles are not being evenly distributed. So remember that an egg not only has to have chromosomes, but it has to have all the machinery to build a new organism. So all the cytoplasm goes to this guy. So this guy is not really going to be viable. Now it pauses again. That's why this big line is right here. It pauses again. And it will not continue through the second stage of meiosis unless it comes in contact with a sperm and it gets fertilized. And this is going to happen in the fallopian tube. If it doesn't make contact with that, it never goes through the second stage of meiosis. If it does get in contact with it, this first polar body would just become 2 more polar bodies, which again don't work. And once again, the secondary oocyte becomes a polar body, which doesn't work, and it becomes one guy who's destined to become the egg. That's called an ootid. It was still haploid, and it eventually differentiates into a viable egg, which is called an ovum, which secretes, hopefully, into the endometrium of the uterus, where it eventually develops into an embryo. So let's go ahead and see what's going on. From 1, we don't get 4 like we did with sperm. We only get 1, and this is the egg, but we get 3 polar bodies, which really don't develop into anything. I know, very confusing. Okay, let's just look one more time at a graphic of what's going on. So the ovaries are made of diploid cells, which are oogonium, just like the testes were made in the seminiferous tubules of spermagonium. And those guys can go ahead and make more oogonium, right? But then they eventually differentiate into primary oocytes, right? Now this all happened here before birth, and it pauses, right? And then after birth here, you get ovulation once a month, right? And you get polar bodies, which are no good, and you get secondary oocytes, which are good. And then it pauses again until it actually is fertilized, and then it goes on to be the ovum, which eventually will be used as the egg. Let's just go ahead and wrap up by comparing the two here. Some interesting things here between spermatogenesis and oogenesis, right? So the number of gametes, we said, these guys actually produce 4, and the oogenesis process only continues to make 1, although it makes 3 polar bodies. Something else. This guy, spermatogenesis, is continuous. Once it starts, it goes all the way to the end without stop to make sperm. Oogenesis is discontinuous here. I'm looking for the word here, but I don't see discontinuous over here. Hopefully it would have said that there. In other words, it pauses at 2 places along the line. So once a month it has to be ovulated. That's the first place that it paused. And the second place pauses is hopefully when it gets fertilized in the fallopian tube. So 1 and 4, right? The other thing is that this goes on a monthly cycle here. And this goes on all the time, every single day, right? And that concludes my introduction to spermatogenesis and oogenesis, and those are the process of gametogenesis.